Hi all, welcome back to our YouTube channel. Topic that we will have a look at today is from paper 4, that is valuation and risk models. And topic is option sensitivity measures and the Greeks. And we will try to understand this topic using gamma neutral and delta neutral hedge. So let's look at the question and then I'll give you the context and solution for this question. So in existing short position in delta neutral, so there is some existing short position which is delta neutral, very important piece of information, has a minus 5,000 gamma exposure. So some position, short position, which is delta neutral, but it has negative 5,000 gamma. An option is available that has a gamma of 2 and delta of zero point 0.7. What action should be taken to create gamma neutral position that will remain a delta neutral? So basically the final objective is to create position which is gamma neutral as well as delta neutral, and we are given some option. At this point we will not bother about that. We'll explore understanding first and then the answer will come along for sure. And yes, you will realize that your thought process or ability to think will be stimulated because FRM and CFA are the exams which are like more practical based, not really something which is like quite similar to your academic exams, which are like you just read something and reproduce in the exam, right, and get your degree. Like FRM and CFA are like more practical based. So you will need to like think a lot to to arrive at a right answer. So before I directly provide you the solution, let's look at a few basics. When I talk about delta, let's understand what delta and gamma are before using terms delta neutral and gamma neutral. Delta of the option is basically, if I just refer to the call option, it is how call option is changing when your spot price is changing. So, say for example, if I say that call FCF is the final price. So initially your spot price was say SI and your final spot price moved to SF. And because of this movement, your call price moved to this from initial call price of this. So basically your how call price moved with respect to change in the spot price, that is what your delta is. And further, like what is a gamma? Gamma is how this delta is changing when your spot price changes. So if your spot prices changes from say again from say SI to SF, how your delta initial changes to delta final. Let me make it very simple here also. When your spot price was initial, it moves to the spot final, and what is the corresponding change in the call price? That's what the delta measures. It's a sensitivity of a option price with respect to underlying price. That's the delta. And gamma is how your delta changes with respect to your underlying price change. So these are the basics. And if you are not comfortable with these expression, on the right you see the graphs which are like more intuitive to understand. Uh, on the right y-axis you see the delta value. On the horizontal axis you see the stock prices, and on the left vertical axis, that is y-axis, you see the gamma values. So very important to note, the option that we are trying to understand here, like just for sake of understanding, has a strike price of 25. And if you notice that when the spot is also 25, your gamma is highest. So very important point to note, gamma is highest for at the money options and delta is zero point 0.5 for the at the money option. So these are the two key important things. And if you are like if you are good in mathematics or if you're from the engineering background, you will notice that basically this gamma graph is rate of change of this graph. If I just draw a tangent to this point, if I just draw a tangent to this point, like the point, it is a point 0.5. Delta is point 0.5 here. Like no other line at this graph or this curve here on the left as well as right will not be slanted like this graph. So delta is highest at the money. Sorry, delta is high. Delta is point 0.5 at the money, and rate of change of delta is highest for at the money option. No other line. If you draw any other line on the graph, this red graph, which is like a tangent to this curve, these would be quite flat. This one that you see here, which is when your delta is point 0.5, your gamma is highest. So that's how it can be interpreted. So two bullet points, if you are making notes from our videos, your delta of call option is point 0.5 at the money and gamma is highest for at the money option. So the two important things to note here. And these are the very important formulas which are like use will be used to solve that question that we had. Number of options required to create a gamma neutral position. So formula to create gamma neutral portfolio. So you will need some options to buy or sell, uh, depending on what your existing gamma is. So your existing gamma of existing option portfolio divided by gamma of hedging option. So you will have some other option which will have its own gamma. So you will use that option to hedge your existing position. But what it will, so going back to our initial question. So this one, if you see the initially your position was delta neutral, but when you make it gamma neutral, your delta neutral thing will get distorted. To make it again delta neutral, you had to buy some number of stocks. So it is shares, number of shares that you will buy to make it again delta neutral. And most important, if you are really a good learner, why we use why we use stocks or shares to make it delta neutral? Because shares or stocks delta is one. If you buy or sell stocks in your portfolio, that will not distort your delta neutralness. Very important point to note if you are really like a in-depth learner. So coming back, these are the two formulas that we will be using. So gamma of our existing portfolio, which is delta neutral, is minus 5,000, and we have some other option that we can use to create gamma neutral and delta neutral position. So let's apply these formulas. So number of options, so when I say number of options, the I am referring to the options that you will use. It is given for hedging your existing portfolio. So number of options we will need is equal to gamma of your existing portfolio, which is negative 5,000, divided by your existing gamma of of hedge option. So the option that we will be using for hedging is this one, which has gamma of 2 and delta of zero point 0.7. So I'll just divide it by 2. I'll uh, I'll get, and very important to note, the important signature here, like it has a negative. So I'll just put a negative sign here. So this negative negative will get cancelled and you will get 2,500 positive. That means you will go for long 2,500 options to make your position gamma neutral. But what will happen, because your this option that you used for making your portfolio gamma neutral has a delta of zero point 0.7, it will distort your delta neutralness. Initially, your portfolio was delta neutral, but because you used options to make your portfolio gamma neutral as well, that distorted some delta part also. So what you do, you will you will buy some number of shares. So that number of shares would be equal to, so number of options that you have is 2500, and delta of option is zero point 0.7. And very important, so negative sign, please be very careful of negative sign. In your book it will not be there, but trust me, just keep this negative position, negative sign here, like depending on whether you are referring to delta of call or put, this will be like you have to buy or sell options or shares based on what. In this case we will talk about buying or selling of shares, because we already bought some options to make position gamma neutral. So keep this negative sign here. That will ensure, this is slightly contradictory to what is being mentioned in the book, but keep this sign. This will avoid any confusions. So put your, so because by default what will happen over here, we can think that delta is zero point 0.7, so we can interpret that we are talking about call option. Had this been put option, the delta would have been given negative. So accordingly, this substitution of negative delta would have offsetted this negative sign here, and we would have accordingly got what we need to do. So I would emphasize that keep this negative sign, slightly contradictory to book, but this is what the more accurate approach is. So let's apply this. So number of options that we have is 2500, and delta of option that we used is zero point 0.7. So number of shares we need to make it delta neutral again would be equal to this number of options we had. What we purchased was 2500 into zero point 0.7. So 70% of 2500. So how much it would be, like 10% would be 250. So 250, 250, 250 to 1750. So it would be equal to 1750. And of course, this negative sign here, because delta is positive, number of shares is positive, or yeah, it's long also. So this would be negative 1750. So you will sell number of shares, you will sell to make your portfolio back to delta neutral is 1750. So let's see. So the right option should have long 2500 options and short 1750 shares. So long 2500 options and sell 1715 shares. So right option is option A. So that's how you can easily make your portfolio delta neutral as well as gamma neutral. Like, let me rephrase the order. You can make your portfolio gamma neutral and delta neutral. And yes, if you like video, please like, don't forget to like, comment if you have any doubt, and subscribe to our channel if you haven't yet. And yes, please, please, please do like, comment, and subscribe to our channel, and share with your peers too. It will help them as well. It will help us also getting maximum reach. Thank you for watching and staying till the end of the video.